maximum and minimum. We have also absolute or local, global or local, maximum and minimum values. We have two theorems, two important theorems here, the extreme value theorem and Fermat's theorem. And finally, the most important two parts of this section are the last parts, the critical numbers, what they are, and how to find them, and how to use the closed interval method to find the absolute minimum and absolute maximum. I think we have achieved these objectives in the previous class, if you remember. We've done all of this. What is remaining is just the last part of this section. But let's do short or quick review for this section. So we have defined the absolute maximum and the absolute minimum value of a function to be the largest. The absolute maximum is the largest or the highest point of the graph, on the graph, and the absolute minimum is the smallest value, the lowest point on the graph. The local here, it should be near a point. So it shouldn't be for all functions, no, for all the values of x. It should be just for some values near a. So we should have open interval. When we talk about local, it should be over open interval. If you don't have open interval, you don't have local. So at the end of the interval, you cannot talk about locality here. When you should say local, it should be from the right and from the left. You should have open interval that contains C. I think also we had some examples. I think this is an example about a function that has maximum and minimum, and the derivative is 0 there. But here, look at this function. It has no maximum or minimum. Even there is a horizontal line here. So the derivative is 0. But there is no maximum or minimum here. So it has neither. The extreme value theorem, what does it say? It is important theorem. This theorem says that if f is continuous over closed interval, then for sure 100% it has absolute maximum or absolute minimum, and absolute minimum both, and it has both absolute maximum and absolute minimum inside this interval. And this is clear, by the way. If you look at the geometrical meaning of this, that this is the value of the function at A, the value of the function at B. Since the function is continuous, so if this is the interval, you have interval A and B. Let me explain it with the full screen mode. Oh, it will not come. Anyway, so if you have it, this is A, this is B, and the function is continuous. So it means that it will, let's say it starts here. So it will do whatever, but it is continuous. So for sure it will be, I don't know how it behave, but let's say whatever, it is continuous. So for sure it has a absolute maximum and absolute minimum inside this closed interval. But you should be sure about two issues, that it should be continuous and the interval should be closed. If you lost one of these two conditions here, like here, without the continuity, you cannot have absolute maximum. Here, you cannot have here absolute minimum or maximum, both, if you lost the closeness of the interval. Now, when you have, of course, when you have a local maximum or a local minimum at some points, then the derivative will be 0 at these numbers. And this is what Fermat's theorem says. It says if you have local maximum or minimum at some number C, then the derivative at that number is 0, provided that the derivative exists. So you have two conditions. If number one, f has a local maximum or minimum at C. The second condition, the derivative at C exists. If these two conditions are satisfied, then you will have the following conclusion. This implies that the derivative must be 0. If it exists, it must be 0. But be careful, the opposite of this theorem is not true. What does that mean? If the derivative is 0, It doesn't mean that there is a local maximum or minimum. And the cubing function is the best example for that. This is a function that its derivative is 0 at 0. The derivative at 0, it is 0 because this is the derivative. But there is no maximum or minimum values at c, at c equals to 0. What is wrong with that? Because the converse of this theorem is not true. This means that if the derivative is 0, it is not necessarily to have local maximum or local minimum. Another example about function it has here log at 0, there is a minimum, absolute minimum, and it is not at the same time, of course, but it is not differentiable at 0. You remember that the derivative at 0 of the absolute value function does not exist. So you have to be careful when you apply the Fermat's theorem. Now the critical numbers. What is the critical number of a function f? Is a number in the domain. So this is condition number 1. It should be in the domain. And secondly, it should be either the derivative of the function at that number, it is either 0 or does not exist. So you have two conditions to check. In fact, you need to do three things. You need to find the derivative, put it equal to 0. Find the derivative and look where it is does not exist, and check are they in the domain or not. And we had this example in the previous class, if you remember. We had the derivative in the most simple form. Now put it equal to 0 and solve the resulting equation, and you will have a number, a solution for this equation. Check, is it in the domain? And you know that the domain of this function is all the real numbers. So it is given, not given for you. It is not restricted. It is all the real number. So it is in the domain. So because it is in the domain, then it is a critical number. Now, ask yourself, where is the function does not exist? And you know that this function does not exist if the x is 0, the 0 of the denominator. And 0 is in the domain. So it is also a critical number. So here you have two critical numbers. But this means, it doesn't mean, ya shabab, that you have a maximum or minimum at these numbers. And this is exactly what this theorem says. It says that f has a local maximum or minimum at c, then c is a critical number. So it is this way, but not the opposite. If c is a critical number, it could be a local maximum or minimum or not, because of the derivative, the case of the derivative does not exist. If the derivative is 0 and it is in the domain, you may have it like that, like the x cubed function, if you remember. Remember just x cubed. Now we have the most important part, as I said in this section. In this section is the closed interval method. What is this method about? When we use it, we use this method to find the absolute maximum and the absolute minimum values of continuous functions over closed interval. So we should have also the continuity and over closed interval. This is what they call it, the closed interval method. So what you should do to apply this method? First of all, you need to find, you need first of all to check that the function is continuous over closed interval. Second, you need to find the values of the function at the critical numbers. So you need to find the critical numbers and then evaluate the function at these critical numbers. The critical numbers, they not necessarily to be at the end points. So here it should be over closed interval, but the critical numbers usually will be some numbers between a and b, not necessarily equals to a and b. Usually this will happen, Shabab, because you know the derivative, for example, the domain of the derivative is usually smaller than the domain of the functions. Next, what you need to do, you need to find the values of the function at the end points of the interval. At a, you need to find f at a and f at b, the end points. Then the largest value of these from step number 1 and step number 2 will be the absolute maximum. And the smallest will be the absolute minimum. It is better to have this example, and we did, I think, in the previous class. No, I think We have stopped at this example. So find the absolute maximum and absolute minimum values of the following function. And over restricted domain, طبعا. Here he gave you the closed interval. Without this, you cannot apply this method. You can find the absolute maximum and minimum, but not by this method if you want to talk about it in general. So now this is x cubed minus 3x squared plus 1. To apply this theorem, you need to check the continuity. This function is a polynomial, so it is continuous everywhere, and it will be by default continuous here. You have closed interval. Now you need the critical numbers. So to find the critical numbers, you need to find the derivative. Find the derivative of this function, 3x squared minus 6x. Now factor it, because you will put it equals to 0. So you will put this equation equal to 0. Now when this equals to 0, this means that x is what? 0 or x is 2. You need to check, Shabab, don't forget that. You need to check, are they inside this interval or not? Are they or not? X equals 0, is it there? Yes.
Yes.
Equals 2 is there. So both of them are in the closed interval, because we mentioned here that these n must be, the critical numbers must be in this interval. So here we are. These two numbers, x equals 0 and x equals 2, they are inside this interval. So we did step number 2. We did find the critical numbers. We evaluate the function at these numbers. Now what is remaining is to evaluate the function at the end points. So we need to find now, first of all, we need to find f at 0, by the way. I think this is the next step, yes. Find the value of the function at 0, but go back to the function, not to the derivative. For the derivative, if you bought them, you will get 0 for sure. Now go to the function, but x equals to 0. It will be 0, 0, 1. And but x equals to 2, it will be 8 minus 12 plus 1, it will be negative 3. So now you need to make a table of values like this. You need to say this is x, this is f of x. F of x. I need to put my screen down to be able to write. So it will be f of x and x. So when x is 0, f of x is 1. When x is 2, f of x is negative 3. We need to do more. What we need to add, we need to evaluate the function at the end points of the interval. So at a half and at 4. So what would be the value of the function at negative a half? At negative a half, put it here. It will be negative a half to the power 3, which will be negative 1 over 8. Be careful when you calculate, do this calculation. 3 times 1 over 4, it will be 3 over 4 plus 1. So in the next step, you will say negative 1, negative 6 plus 8 all over 8. And this is 8 minus 7, it is 1 over 8. So this is 1 over 8. And at 4, here it is. At 4, it is 17. Now what you will do you remember the last step? It was about what? Now you will compare these 4 values that you have. Which one is the bigger? 17. So this is the maximum, the absolute maximum. And where is the smallest? Negative 3. So now the absolute maximum is f at 4, which is 17. This is the absolute maximum. And the absolute minimum value, it occurs at 2, and it is negative 3. Is that clear, ya Shabab? Did you got the idea? Because
Yes,
this is what you are going to do, ya Shabab. Most of the questions from the sections are about this issue. So let's take another example. Yes.
First, we have to find the critical numbers, and then we test the endpoints.
Yes, this is what we did. This is the method. If you read the method, how to find the absolute maximum, you need to find the value of the function at the critical numbers, then the value of the function at the end points. Because it might be that the absolute maximum is at the end of the point. And as happens here, look, the absolute maximum, it was at the end point. This is usually, ya Shabab, for most of the continuous functions. If you cut it here, You didn't take the whole domain, just you take a restricted domain from here to here. So this here you will have here the absolute maximum, here you will have the absolute minimum. Is that now answer your question?
Yes, thank you.
Another example, but I think you need, according to your book, it was mentioned here that you need a calculator. But let's just get the idea. Forget about the calculator. If you have, you can have a question like this, but you don't need to use a calculator. We will give you some numbers that can be compared without a calculator. Now find the absolute maximum and minimum values of this function. This is a geometric. It is a sum of algebraic and geometric function, and we have closed interval. So now what we need to do, first of all, we need to check, is it continuous, ya shabab, over this interval? Is this function continuous here? Of course, sine is continuous and x is continuous. The sum of them or the difference between them is also continuous. You need to find the derivative. This is the second step. The derivative of x is 1, the derivative of sine is cosine. Now you need to put the derivative equals to 0. This derivative must be equals to 0 to find the critical numbers. So you have 1 minus 2 cosine x equals to 0. This will give me that cosine x is a half. Am I right? It will be negative 2 equals to 1, negative 1, then cosine x will be a half. So cosine x equals a half. What is x, ya shabab? Cosine x equals a half. What is x? Think.
Pi over 3.
Pi over
Pi
3
over
plus
3
n pi.
plus n pi. Yes.
Pi over 3 plus.
N pi.
But there is an interval.
Aha! Focus, ya shabab. It is a given interval. So it is pi over 3 and what? Cosine is positive. Cosine is positive. So we are in the first quadrant or the third quadrant. Do you remember that?
Fourth.
So in
Fourth.
the fourth quadrant, yes. So the cosine x equals a half. In the first quadrant it is pi over 3. In the fourth quadrant it is what?
5 over 3 pi.
5 pi over 3 to n minus 1 over pi over n. You remember that? So this is 3. This will be 6 minus 1. It will be 5. So it is 5 pi over 3. Be careful about this, such a step. طبعا someone he said, why I didn't say negative pi over 3? Because yes, it is. Look here, it is between 0 and 2 pi. It should be greater than 0, not less than 0. You cannot use the negative angles here. So x is pi over 3 and 5 pi over 3. And for sure, you need to check, shabab, are they here or not? And also, you need to check that you take all the numbers that they are inside this interval. You didn't forget one of them. So now these are two critical numbers. What else we could have critical numbers? Where it does not exist? This derivative does not exist at some points, or it exists always. It is cosine, shabab. Cosine x is continuous everywhere. So it exists always. So indeed, it exists always. So we have only these two critical numbers. So let's evaluate the function at them. The value of the function, the original function now, here. The value of the original function, if you substitute here, you will get 0. What is the benefit of that? So evaluate the function at these numbers. So you have here pi over 3 minus 2 sine pi over 3. Sine pi over 3 is what? Is square root of 3 over 2. So you will have square root of 3. Now this is the number. You can estimate this number. You remember just that pi is approximately 3.14. And this is square root of 3. It is like approximately 1.7, something like that. I'm not sure. So it is a small number, because this will be 1 point something minus 1.7. It will be negative, some negative number. Here it is, a negative 0.68. And this is what I said, you may need a calculator, but sometimes it will be easy for you to compare even without a calculator. Now this is the value of the function at pi over 3. For the value of the function at 5 pi over 3, it is this one, and clearly this is bigger than this one. This is positive number. It is 1.7 plus 5 pi over 3. It is in fact like
almost
more
half.
than Yes, 15 over 3, more than 15 over 3. So it will be like 5 plus 1.7. Yeah, it is 6.9. So you can estimate it, approximate it. Now, clearly this could be absolute maximum. This could be absolute minimum. But we need to do one more thing. What is it?
The boundaries.
The closed interval.
Substitute
Should find the
interval
value
on
of the function
the
at 0 and the
early-
value of the function at 2 pi. This is what is remaining. The value of the function at 0, it is what?
0.
0. The value of the function at 2 pi, it is 2 pi.
2 pi.
So now 2 pi, it is almost 6 points something. Is that right? So because it is 3.14 times 2. Now you can see clearly, ya shabab, which one is the largest? This is the largest. So the largest is this value, f at 5 pi over 3. And the smaller
Pi over 3.
not pi over 3.
Yeah.
At
F pi.
at
Yes.
pi over 3. What is it? It is negative 0.6. So here it is.
That's pi over 3.
This is the local. This is the absolute minimum, and this is the absolute maximum. Done. Any question, shabab? That's it. This is 4.1, shabab. You can check now the objectives. Are they achieved or not? Do you know what we mean by absolute maximum and absolute minimum values? Local maximum and local minimum, the extreme value theorem, Fermat's theorem, critical numbers, the closed interval method. You should be aware about this. If you have a question from this section, it will be mainly about two things: the critical numbers and how to find the absolute maximum and the absolute minimum by using the closed interval method. And you can check all the exam questions. You can find that most of them are about this issue. Let me now give you an exercise to practice to make sure that you got the idea. So these are some suggested exercise for you, Shabab, to practice, and I will give you 2 or 3 minutes to solve this. I think 2 are enough. 2 minutes are enough. Please, you need here to find the absolute maximum and the absolute minimum values of this function. This is similar to the example that we had on this interval 0 and 3. Please, take a paper and pen and practice. If you forgot, just you need to do as we did in these two examples. It is similar to this one. What you will do, check is it continuous over the closed interval or not, find the derivative, find the critical numbers, find the endpoints, and so on. So then the largest, you will apply this method, the closed interval method. You will find the values of the critical number, the values at the endpoints, compare them. Take the largest to be the maximum, the absolute maximum. Take the smallest to be the absolute minimum. Yalla ya shabab. And I will launch a polling for you, but let me give you 1 minute. After that, I will launch it. Allah la ilaha illallah. I have modified, ya shabab, the announcement of the quiz to be next class, inshallah. I think it is not professional to delay this quiz more. So let's take it next class and start thinking about the next ones, inshallah. If you got an answer, you can choose what is your right answer now. Don't forget that you want to find 8m capital plus m small. So you need to multiply the absolute maximum by 8 and add to it the absolute minimum. MashaAllah, 10 students. Try يا شباب. Think, use your mind, practice, check that you got the idea or not. It is not an exam or a question. It is just about learning. Try. If you got the right answer, it's okay. But if you didn't, no problem. You are learning here. $18 students only. More votes. So far, we have only 5 students got the right answer. Among 23, only 5 students got the right answer. So I'm gonna end the polling يا شباب. So to show you the results. MashaAllah, you have been distributed over all the choices. 3 with A, 10 with B, 2 with C, and 9 with D, and 7 with E. And the right answer is D. So the people who got D as a right answer, they are right. It is the right answer. It is so easy question, Shabab. I don't know why you lost or you missed the true answer. What you need to do, Shabab. First of all, is this function continuous?
Yes.
Yes.
Over this closed interval?
Derivative.
Yeah. So we can apply the closed interval method. So what we will do, we'll find the derivative, which is 3x squared minus 12. Am I right? Now you need to put this equals to 0 to find the critical numbers. Of course, it exists everywhere. The derivative exists everywhere. So there is no point at them, and the derivative does not exist. So it is just about putting the derivative equals to 0. So this means what? This means that 3 times x squared minus 4, we take 3 as a common factor, equals to 0. Which means that x squared equals to 4, which means that x equals to 2 or negative 2. Is that right?
Yes.
No, negative 2 is
I
not a
know
Negative.
the
Reject.
mistake is given from here, I think. Some of you, they did a mistake here. This function, ya shabab, is not in this interval. It is not. So this is rejected because it is not between 0 and 3. We will take only the points that they are between 0 and 3. This is why we said, ya shabab, that the critical number must be in the domain, in the given domain, the restricted domain here. So here we have only x equals to 2. So if you choose negative 2, you did a mistake. Now this is step number 2, if you remember. Step number 1. Step number 2, what you will do, you will evaluate the function at 2. What is the value of the function at 2? It is 8 minus 24 plus 2, which is what?
minus 14.
Negative
Minus
14.
14.
Now we need to evaluate the function at the end point. So we need to find the value of the function at 0, the value of the function at 3. Of the function, don't forget that, not the derivative, the function. So evaluate there. At 0, it will be 0, minus 0 plus 2, it will be 2.
2.
At 3, it will be 27 minus 36 plus 2, which will be what? Negative
-7.
7. Is that right? Negative 7. Now, which one is the, what is M capital, the absolute maximum? What is M capital?
2.
2. Is that right?
2.
This one. This is M capital,
Yes.
the maximum. Now, what is the minimum? This one, the smaller.
14.
This is the minimum. This is M. So M small is negative 14. And 8 M capital plus M small equals to 8 times 2 plus M small plus negative 14. 16 minus 14, it is 2. Okay, any question, ya shabab? If you had a look at the old exam questions, you will notice that most of them are about the same idea. So the local minimum of this one. By the way, this one, I think we should put it in 4.3, not here. I have noticed that when I was trying to give you this to practice on it, I noticed that you need 4.3 here. You can use, by the way, you can use the ideas that you have here, but we will delay this question. I think it is better to have it on 4.3. Because you need there the second derivative. We will see that, and you can look at the old exam. Similar idea. You need to find the absolute minimum and the absolute maximum of a function. Most of them are solved. Absolute maximum, minimum, the critical numbers. Most of the questions are about these issues, the critical numbers, and so on. I think it is time, Shabab, to move to, you may have this kind of tricks, طبعا. It is time to move to the next section if you don't have any questions. Let me end the show and go to the next section, 4.2. The next section is about the main value theorem. And also the rules theorem. So we have here only two main ideas, the rules theorem and the main value theorem. And of course, they are kind of also other mathematical applications of the derivatives. So let's start with the rules theorem. What does this theorem say? It says that if you have a function that satisfies the following three conditions, the following three hypotheses. Number one, f is continuous on the closed interval a and b. F is differentiable on the open interval, not necessarily here. The function is not, it is not necessarily to be differentiable at the end points, because usually, Shabab, you know that, as I told you, that the domain of the derivative will be smaller than the derivative, the domain of the original function. The third condition is that the value of the function at the end points are the same. F at A is the same as F at B. If these three conditions are satisfied, then what is the conclusion? Then there is a number, there is at least one number. I think they should add it here. There is at least one number in this interval such that the derivative of the function there is 0. And you can see that the geometrical description here, the geometrical meaning of this theorem says, if you have a function that has the same, look here, f at A, it is the same at f at B. In all of these, look. If f at A, it is the same as f at B, or for any closed interval in the domain, then for sure, there is a point there at which the derivative is 0. You will have, in the typical case, a horizontal tangent. Like here, even if the function is constant. it is all equals to the same. So simply, ya shabab, if you have a function that is continuous, let's say this function, continuous, if you take any 2 points, like this A and this is B, and it happens that the value of the function at these 2 points is the same, like here. So for sure, in between them, there will be a top and a bottom here, because it should go back this way or this way, or at least in the lowest case, it will be constant like this. It will go this way. So this is what the Rolle's theorem says. And one of the most applications of this theorem is solving equations. If you have an equation that you cannot solve, you can use, of course, this theorem to solve it, or to approximate or estimate the solutions. Also, you can think about the rate of change theory, problems. If you remember the rates of change problems, they are kind of applications of Rolle's theorem. How? Look, if S equals f of t here, S equals f of t, it is the position function, the distance function of some object or particle. Then what is the meaning that you have two numbers, let's say A and B, which means that t equals to A and t equals to B, 2 different times, so 2 different times, but the value of the function is the same at these 2 different times. What does that mean? It means that at different times, the distance will be the same. If this happening, then there is a time between these 2 times at which the derivative of the position function, let's say C between A and B. So at some time between A and B, the derivative will be 0. What does that mean? It means that the velocity at that time will be 0. You can just think about a ball. If you're throwing a ball directly upwards, it will be the velocity will be 0 here. So there is here a number at which the derivative will be 0, and of course over the same distance here. So it has the same distance from f of A to f of B. So it says that there is some instant time between A and B if they have the same place at the same place after at 2 different times. So if it is at the same place at 2 different times, like here, the time here t1, this is t2, so it is at the same place but with 2 different times. So in between these 2 different times, the particle will be at rest at some point, at some time between them. The derivative will be 0. So this is a kind of relationship between the Rolle's theorem and the rates of change problems. As I told you, one of the main applications of this theorem is solving or approximating or estimating solutions for equations that we cannot solve algebraically exactly. You cannot find the exact easily. You cannot find the exact solution of this one, of this equation algebraically. You can see clearly, Shabab, that what we want here. We want to prove that this equation has exactly one real root. Exactly one, not more than one. Not none, not more than one. So how to prove that? First of all, I think you remember from section 2.5, when we studied the continuous function, we studied there what is called the intermediate value theorem. So how to know, Taban? I don't know what is the solution of this equation. I don't know. What are the x-intercepts? Also, you can use, by the way, the synthetic division and the theorems that you learned in MATH101, if you remember, to approximate or to find exact roots in, if you can. But of course, here we want at least to estimate it. Is it positive? Is it negative? Is it small? Is it big? Is it between 0 and 1 or between 2 and 3? I don't know. So with the help of these theorems, we can decide about it. So if you remember the intermediate value theorem, Shabab, the intermediate value theorem, section number 2.5, we can use that theorem to show that this function, so we will call this f of x, to show that this function, this equation has a solution. But we cannot guarantee that we can prove that it is only one. So let's find that it has one or two or three, at least one. So we will use the intermediate value theorem. Do you remember, Shabab, how to use it? It was about what? It says that if you have, for example, a value of the function here, this is b. Let's say that f at b is positive and f at a is negative. This is here. And it is continuous. Because it is continuous, it must cross the x-axis at least once. At least once. And if you أسوأ الأحوال, it will do this. So it must cross the x-axis at least once. So there is a number between them such that the value of the function will be 0, because 0 it is between a and b. Do you remember now the intermediate value theorem, Shabab? So now you need to think about what are these two numbers. What is a and b, that for them one of them is positive, the value of the function at one of them is positive, and at the another one is negative. Simply, you can think about what? 0, مثلا at 0. What is the value of the function at 0? It is negative 1. 0 plus 0 minus 1. Take 1 for simplicity. If it doesn't work, go to 2. F at 1, what is f at 1? 2 minus, it is 1. So this one is negative, this one is positive. So there is a number between them. So there is a number c between 0 and 1, at which the function will be what? The function at which will be what? Positive. It will be 0. Because that one is positive, that one is negative. So there is a root between them. There must be a root, an x-intercept between them. Because otherwise it is above the x-axis and below the x-axis. How they can connect each other if they didn't, if I will not cross the x-axis at some point between them. So now we know, look, we started with, when we started, we don't know anything about the root, the 0, the x-intercept. But now I know that it is between what and what? Between 0 and 1. So I estimate it now. I approximate it. So I know that this function has an x-intercept between 0 and 1. Now the question is, how can I prove that it is the only one? There is no others. So how to prove that between 0 and 1, the function will cross once only, not more than once, not like this. How to prove that? We will use the rules theorem. And we will use the rules theorem. Do you remember the rules theorem says what? It says that the function must be continuous. We have this continuity. It is differentiable. We have it because it is polynomial. And this is the most important part. We have f of a equals f at b. So we should look after some points a and b, at which of course they are the same. Now this is 0, this is 1, ya shabab. So to assume, to prove that there is only one x-intercept, what we will do, we will assume that there are two. خلينا نقول إنه في 2 x-intercepts. يعني في A وفي B والf of A هو نفس f of B equals to 0 بما أنه x-intercept y equals to 0. So we should, if we don't get any problem, it means that there are 2. But if we get something wrong, it means that this assumption is impossible. So this is what is called, ya shabab, proofing by contradiction. Do you have an idea about it? So we will argue by contradiction. الإثبات باستخدام النقيض. هذا من في اللوجيك في اللوجيك of mathematical logic. في طريقة أساسيات الرياضيات من طرق البراهين يا شباب. To prove one of the most effective and shorter kind of proofs is the proof by contradiction. إيش هو؟ أنت تفرض عكس اللي تبغاه. يعني you will assume the opposite. If you got something wrong, it means that your assumption was wrong, and accordingly its converse is true. لاحظوا معي هنا. أنا ودي أثبت الآن إنه there is only one x-intercept. So I will assume that there are more than one. Let's say there are two. So we will suppose that there are two roots, two solutions for this equation. This means, of course, that the value of the function at these two solutions is 0 because they are solutions. And now this function will satisfy the rules theorem. يعني it is continuous on a closed interval and f of a equals f of b. Then by the rules theorem, there is a number c at which the derivative equals to what? To 0. So let's see that. What is my function? My function is this. What is the derivative? The derivative of this function, it is what? 3x squared plus 1. Now solve this. Put it equals to 0. Here it is. Put it equals to 0. Can you solve it? It has a real solution? No. Impossible that positive number equals to negative number. It is not a real number. So this equation has no real solution. This equation cannot be never ever 0 at any real number. So what does that mean? Does that mean that the rules theorem is wrong? No. It means that my assumption, this assumption, it was wrong. What I assumed here, this assumption here is not true, is false. Its converse is true. So there is no two roots. It is only one root because I got a contradiction. Therefore, the equation cannot have two real roots. It has only one. And I have proved that there is a root. There is a root. But is it unique? Is it only one or we have more than one? And the second theorem, Shabab, is the main value theorem. I think we have 2 minutes. Let's explain the idea of the main value theorem. It is a generalization of the rules theorem. The rules theorem is a special case from here. So the main value theorem says that if you have a function that is continuous on the closed interval and differentiable over the open interval, and then there exists a number between a and b such that the derivative at that number equals to the average. The rate of change, you remember, it is equal to delta y over delta x. F of b minus f of a ala b minus a. If you did the cross multiply, you can write it this way also. We will use this, of course, later in this chapter. Heavily, طبعا. Now, ya shabab, I said that the rules theorem is a special case. Why? In the rules theorem, we have this condition, and we have a third condition. The third condition that f of a it is the same as f of b. What will happen if f of a is the same as f of b? This will be what? It will be 0, and this will be 0 over b minus a. It will be what? 0. So this means that the derivative at c will be 0, and this is exactly what the rules theorem says. So it is just a special case from this theorem. If you want to understand the geometrical meaning of this theorem, it is not difficult. This is f of c. This is the derivative at c equals to 0. Equals to f of b minus f of a over b minus a. And this is f of a, and this is f of b. This is a, this is b. What is the meaning of that? That when this derivative equals to this, here, this is a tangent, a tangent line. The derivative at the tangent line, it is equals to what? To the slope of the tangent. Is that right? And what is this? It is equals to the slope. Let's call this one secant. It intersects the graph twice. So it means that the slope of the tangent will be equals to the slope of the secant, of the parallel secant. So the line that will join these 2 points, A and B, will be parallel to the tangent. This is the meaning or the geometrical meaning of this theorem. It says that the slope of the secant line of the function at A and B will be parallel to the tangent line at some point in between them. That's it. This is all what we have for today. See you inshallah next class, Shabab. Don't forget that we have a quiz next class, inshallah. If you have any question, Shabab, before I leave to go to the another class.
السلام عليكم دكتور.
السلام ورحمة الله.
دكتور بس بسألك تدرس ماث 102 الترم الجاي؟
Honestly, I don't know.